Are there any questions at this point? Are people reasonably comfortable with the MapReduce workflow and the programming model?
Yeah, we have a question on UCLA.
Yes.
The question is on that reducer side on your slide, you showed 3 reducers. What happens if one of the reducer dies? Does it have to go start the map all over again?
So that's a very good question, and actually I'll talk about that in the next slide a little bit. So the question pertains to fault tolerance, what happens if a reducer dies. The basic mechanism that MapReduce provides is to re-execute the task. So a basic assumption that is made with any MapReduce application is that the operations are idempotent and they can be repeated without any side effects. So what this means is that you can execute either a mapper or a reducer if it fails. If a mapper fails, that's fine because you can simply use the input data on another machine and re-execute the mapper on that. So there are no dependencies for the mapper. For the reducer, now it depends on the outputs that are coming out from the mappers. If a reducer dies, you simply reassign that reduced task to a different machine, and then you have to resend the data from the mapper. And the data is sitting on the mapper, so the data is in secondary storage already, so you can fetch the data from it. Now if a mapper dies, and the data is not available anywhere for the reducer to consume, then you may have to re-execute the mapper as well. So I hope that answers the question. In addition, another mechanism that is typically provided is what is called speculative execution. And what this means is that if some node or some task is running very slowly, you can launch a copy of that task on some other machine, and then basically get the results back from the first task that finishes. Okay, so again, this is using the property that these operations are idempotent and they can be executed without any side effects. So this is basically used to avoid stragglers for very slow nodes, which may drag down the whole computation. Okay, so if you see some of these, say, load hotspots or other kinds of problems occurring in the system, you can try to execute up to them by launching some of these replicas of the process. So Hadoop is an open source implementation of MapReduce framework, and this is an open source Apache project, so anybody can download and use it, and in fact, people can also contribute to it if they want. The development again started at Yahoo, but since then it has been picked up by a large number of developers, and a lot of people are contributing to this project now. So it basically provides an underlying MapReduce implementation, but in addition, there are several other tools and projects and languages built on top of MapReduce as part of this project. These include things like high-level languages such as, say, Hive, etc., some of which I think will be discussed later on today in some of the other talks. Hadoop is implemented in Java, and again, it was the primary data analysis platform at Yahoo, where they are running it on a very large number of machines. But as I mentioned, it's now being used widely by many other companies as well as institutions. So the primary components of Hadoop include the Hadoop file system. So this is a distributed file system which is overlaid on top of the local file systems of the machines in the cluster. So you may have, say, a large number of Linux boxes that you have put together in the cluster. So what Hadoop file system will do is basically use the local Linux file system for storing the files, but it has a master server which keeps track of which file is sitting on which machine, and it provides the abstraction of these data chunks for the purpose of running MapReduce jobs, but these chunks are essentially stored as local files on the local machines. In addition, HDFS also provides replication. where each data chunk is replicated to a few different machines so that you can achieve some sort of fault tolerance. In addition, it keeps track of which chunks are sitting where, so when you are executing the MapReduce tasks, then you can basically take advantage of this locality information. So you know which map task should be executed where, depending on where the chunks are located. The other part of Hadoop is MapReduce itself, which implements the programming paradigm that we just discussed. And again, it has mechanisms for fault tolerance, such as re-executing the tasks, speculative execution, etc. And again, it optimizes the task placement based on where the data is sitting. So it uses the locality information from SDFS to do some of that. And these are the primary components, but in addition, as I mentioned, there are other components sitting on top of SDFS and MapReduce. So for example, they have a NoSQL database sitting on top of SDFS. They have higher-level data analysis programming languages, which use MapReduce as the underlying execution platform, such as Fig. And I believe you'll hear much more about those in the other talks today.